Hi, I'm Stefan Hill. I'm the portfolio leader for high-value biorefineries. Hi, today I would like to talk to you about biorefineries in the context of New Zealand. It's fair to say that anything that can be made from oil today can be made from a tree tomorrow. But what is a biorefinery, or a refinery for that matter? Well, simply put, it's a collection of processes that take some sort of crude feedstock, and currently that's oil mainly, but we're more and more progressing into a world where wood and biomass will be that feedstock. Then it uses a range of processes which cover mechanical, like a pulp mill, thermal, chemical or biological. Now, from these processes you can generate a range of materials, and that's by either breaking down the crude feedstock or by building up the feedstock or by transforming the feedstock into a new material. The idea being that you produce a wide, diverse range of products. Not any one product can make a biorefinery or a refinery viable for that matter. So what we end up is with a volume value pyramid. This is where there is a small volume of high value materials, such as intermediates for pharmaceuticals or cosmeceuticals. And then going down, we end up with things like additives for food or feed for animals, and then down through into larger volumes and higher value and lower value, of fermentation and commodity chemicals. And then finally, with what's left over, you can turn into process heat. But the concept is it is an integrated process. So currently we've got some options. We've got the old oil-based way of running a refinery, or we've now got the options of looking at tree-based feedstocks for refining. And so the two options are really comparing an unsustainable resource, in the case of petroleum or oil products, and versus a sustainable resource, which would be biomass, and we're talking about trees here today. In the case of oil, oil is, even though we have lots of it, it is really an unsustainable resource, in that the conditions in which oil formed on the planet billions of years ago are unlikely to occur again. Now, in terms of the biomass, we have more options. With the oil industry, they've got oil, and that's what they're starting with. In a biorefinery with using biomass, and particularly trees, we get to choose. So we might be looking at just putting in general tree biomass to produce the products, or alternatively, in some cases where there's much higher value, you could be looking at a purpose-grown crop to maximize those specific products. Now, it doesn't mean that we go without the materials which we're used to using in our day-to-day. In the case of the oil versus plant refineries, we can generate exactly the same materials. So an example on the right-hand side is we have a compound called methacrylate, and it's used in a lot of materials, like paints and probably the glasses you're wearing if you wear reading glasses. Now, these materials can be made either from currently made from the oil industry. Now, that goes through a process you can see on the right-hand side column, where the oil gets dredged up and then shipped in barrels, goes to a refinery, where it gets converted through a four-step process into this methacrylate that we then use in our paints, for example. Now, on the left-hand side, you can see it's sort of a couple of steps less for us to take a compound from plants and convert that into the same compound. So again, we're looking at complete replacement of oil-based products with plant-based products. Now, one of the advantages of the plant-based products is that we now have the opportunity to look at new materials, and rather than saying, well, this is the material I've got from the oil industry, so this is what I've got to work with, we can look at saying, well, what actually would we be looking to use, and is there something better, and how would we design that from a bio-based sustainable point of view? But we have enough oil, right? So really there's no problem. I mean, why are we even bothering? Well, the Stone Age didn't end because of the lack of stones, and the oil age will end long before the world runs out of oil. And the reasons for that are quite clear. You just have to look at the current climate change numbers, and they are quite spooky, and we need to do a lot more if we want to even get close to the numbers of reproduced climate change increase by 2030, 2050 and beyond. So basically, the reason we'll be giving up on oil is because we only have one planet to live on. And continuing as we have been will make living on the planet harder for the next generations and the generations after that, unless we start to do something now. And one of the answers is looking at sustainable biorefining to replace oil refining. So what are we sort of talking? Well, in some ways, we're not talking something new. Um, the oil-based economy is not sustainable in the long term. It also hasn't been around that long. We're only talking 150, 200 years or so where oil's been the main material that we've developed our economies on. Now, prior to that, they didn't have the options and everything was agrarian and you lived off the land. Now, one thing that has occurred from the oil age is that we've developed a whole lot of science and technology over that period. So as we move away from using oil, we won't be living off the land, we'll be living with the land, and we won't be going without any of the materials that we've come to know and love. In fact, if anything, they will be more available and perhaps deal with some of the problems we have around poverty due to lack of resources. So trees, we normally think of trees, we turn them into a piece of timber or some pulp, and that gets converted into paper, and these are all valid uses and they'll continue to be valid uses time immemorial. But some of those materials we can make from either the wood, the pulp, the bark, the needles, or some of the extracts from the tree itself can already be used in a range of materials far beyond what we currently see wood as having its mainstay. So some of these chemicals can be converted into materials which would replace oil-based or be new materials which cover pretty much a large range of industrials today, including aviation, packaging, printing, automotive, electronics, pharmaceuticals, chemicals, textiles, and of course energy. Now, these are become a higher proportion of these industries as time goes on. So, is it viable? Can we actually have a biorefinery, or is this just a joke? There's a working biorefinery in Norway run by Beauregard. Now, the main biorefinery is in Sharpsborg with 5 other biorefineries which are outside Norway. They've got over 1,000 staff and they are truly an integrated biorefinery. Now, they are only utilizing what we'll call the key components of wood. So we're talking hemicellulose, lignin, and cellulose. But they produce a diversified portfolio of products, and they use the underutilized wood and waste streams as their feedstock. Now, of that feedstock, that wood feedstock they get in, 82% of that is used to make biochemicals and biomaterials, specifically to replace oil-based products. Most of the remaining biomass is then just converted into energy, and because this is energy converted from a tree, it's sort of a zero-sum game with respect to carbon, in that the carbon is young and not fossil carbon. So what does that look like in terms of their revenue and their income and the way they run things? Well, their value pyramid is they have 82% of their materials making compounds. 82% of the wood is going into making compounds and chemicals, and then 12% to heat, and there is a 6% process loss. But their five value areas are lignin biopolymers, specialty cellulose, cellulose fibrils, and biovanillin. Now they do make bioethanol, but I'll leave that off because that's more of a bioenergy matter. So what do their financials look like? Well, in 2020, they actually were making profit. So they were generating in their lignin biopolymers and biovanillin areas about 1,150 NZ per tonne. They were processing about 416,000 tonnes a year, and in their other department of specialty cellulose and cellulose fibrils, they were looking at 1,750 New Zealand per tonne, and nearly 150,000 tonne of material were being processed. Now, what that generates in terms of profit, now by profit I mean minus the cost of materials, service and depreciation of the plant, they were looking at about 215 New Zealand dollars per cubic metre of input wood residues. They currently have an operating profit of around 94 million New Zealand dollars. Their growth rate is about 4.4%, and they have a target return on capital investment of around 15%. So you can see that these are not just conceptual anymore, that a biorefinery using forestry biomass is actually a working, financially viable industry. So what are we doing in New Zealand? Well, in New Zealand, we've started a case study around looking at bark biorefinery. So this is taking the bark residue from the pine forest industry and looking at how we can create value add around it. So this is the 5-year Scion-led MBE funded program. It started in 2018 and will go until 2023. The focus is on delivering a pine bark biorefinery, but it could be extended to other forms of bark or biomass. We're looking at a range of products from commodity to high value. We're working on a zero waste model by converting solid residue into bark briquettes for heat and energy to run processes. And we're partnering with forestry, bark suppliers, large-scale extraction capability, end users on national and international scale, and research providers across the globe. As you can see some of their little badges there. So you can see this is a great interest not only in New Zealand but across the globe on how we can best go about utilising biomass. So in terms of New Zealand, where would we get the bark from? This diagram is a mass flow diagram estimating how bark is distributed from in forest to around the various activities and even to waste in the case of landfill. So we have multiple opportunities of where perhaps we can gather bark that we could have then use as an input for a bark-based biorefinery. And as you can see, there's quite a lot of opportunity in that the amount that's left at stump or left in landing is quite large in terms of bark volume. And if there was a value proposition, then maybe some of that bark could be brought out of the forest. So what are we developing? We're developing a bark biorefinery concept. Now this is to look at taking the bark, which we value at about $25 a tonne, and look at converting it into, in the first case, up to $600 a tonne, and then by what we'll call generation 2, maybe as much as $6,000 a tonne. We'll do this by taking the bark, putting it through some sequential extractions, then as per the biorefinery or refinery concept, it'll undergo some sort of biological or chemical or mechanical treatment to produce some materials. Now, what we're calling generation 1 would be tannins, and its uses can be something like tanning leather, hemicelluloses, which can be input for fermentation or other materials, and then the solid residue for energy or putting back as growing media or indeed animal feed. Then in generation 2, which are the harder compounds to get out, there's less of them and therefore higher value, we're looking at suberins and waxes, which can provide waterproofing and replacement for oil-based materials for waterproofing, and they can go also into a range of materials like cosmeceuticals, nutraceuticals, pharmaceutical intermediates, bioactive antioxidants and antibiotics. Then all of these can be obtained from the extracts from pine bark. So what does it look like in terms of after we've extracted? So we work on that bark is about 4 to 8% the mass of a pine tree. So if we had about 50,000 tonne of bark, what we can expect going through the biorefinery process, we would generate about 1,200 tonnes of suberins, about 800 tonnes of waxes, about 100 tonnes of phytosterols, about 2,000 tonnes of carbohydrate, 4,000 tonnes of tannins, 800 tonne of resin acids, and about 40,000 tonnes left over, which we can convert into energy for running the biorefinery. Now, these would lead into current products. As you can see, the phytosterols are used as a health supplement, to the waxes, which can be incorporated into inks and resins, to the tannins, as I said, for making leather, and then the suberins, which again can be reacted to form hydrophilic polymers for the next generation of Gore-Tex, for example. So what does the value pyramid look like? Well, currently the project is still underway, so we don't have exact numbers to put against this value pyramid. But what we do know is from the cost of these extracts and materials from other processes, that what we'd be looking at is the resins and the sort of carbohydrates for fermentation and tannins are sort of low value, but we have high volumes. And then as we go up, we can convert some of those same materials into high value but lower volume antibacterials and antioxidants in the case of tannins, and we can separate out some of these extracts and convert them into fine chemicals which have a significant price tag attached. So, what are we looking at ultimately? Well, we're looking to develop a tree-driven New Zealand chemicals circular bioeconomy. Currently, a lot of our chemicals are imported, and a lot of those, again, come from the petroleum industry, for example, and it will be touched on by one of my colleagues that we import pretty much all of our plastics. So the idea would be to shift away from economies of scale, which is basically the oil industry, to scales of economy, meaning that we should build biorefineries of an appropriate size for the area that they're in for a specific purpose. Now, it could be that smaller biorefineries, as well as making a specific material, they may also feed into a larger biorefinery that would then be the place that converts things into exportable materials. Global markets are huge. The global market for the kind of high-value chemicals which can be obtained from biorefineries are valued in the US trillions, not billions, trillions. So we don't really have to get in and saturate a market. There are lots and lots of markets that we could be exporting into, and all of them are significantly high value. So in terms of volume, the top five oil refineries produce up to 89 million litres of refined oil per day that go into make chemicals and materials. So that's a huge opportunity for biorefineries. So what will biorefineries do for New Zealand? One thing that COVID has taught us is that New Zealand is an island, and I know that's an obvious fact, but we've been made more aware of the fact we're an island in that the cost of getting shipping to New Zealand has increased dramatically, and therefore we realise that we are at the mercy a little bit of the globe when it comes to some of our core materials that we need. Now, we're not saying we would replace everything that we import by having a few biorefineries in New Zealand, but I'm suggesting that we at least can have a security of some of the supply in case of situations like we find ourselves in at the moment, COVID. So what that means is we'd be looking for sustainable onshore manufacturing of platform and high-value chemicals. That would reduce our reliance on oil-based chemical imports, not to zero, but it would definitely make sure that our key components that we need to keep industries like packaging running would remain running. It also gives us an opportunity for New Zealand to change things around and become net exporters of high-value chemicals. Around the globe, demand for chemicals is only increasing year on year, and New Zealand can be part of that, and we should be part of that. It'll also open new paths for regional-based economies that are uniquely New Zealand, in that we'll be looking at indigenous species. Now, the importance of this is going to be making sure that we are Mātauranga Māori-led, and that there is an understanding and a guarantee that the ownership of the taonga remains in the hands of iwi, and even more so of a particular rohi. Now, that's important because we want to make sure that we can maximise the Maori economy, and we can make sure that that is protected from overseas entities as well. We would be re-envisaging the roles of forestry and pulp and paper industries to meet the challenges of the 21st century. And those challenges are we're going to need more materials, and materials that are going to replace the ones that we currently get from oil-based industries. Now, that's not an easy ask, and it's not something that'll happen overnight. So there's going to have to be an evolution, and no doubt that will start with forestry residues and waste materials, and that will go into biorefineries as is. But over time, I feel there will be a push towards purpose-grown crops, crops that have a specific task in the biorefinery to produce perhaps some of these high-value chemicals that would be targeted predominantly for overseas markets.